So chapter 9 talks about this thing called text processing more, or we're going to deal with more text processing, and we're going to basically get in depth on these things called these wrapper classes. We've covered a few of the wrapper classes. We've just used the integer dot parse and the double dot parse and the I think that's pretty much all we've used. But it allows us to utilize more textual things. So it says the wrapper class for a given primitive data type contains not only a value of that data type, but also methods that perform operations related to the type. So if you remember, primitive data types don't have any methods at all. They don't have anything that we can utilize. Primitive data types are just that. If I make a double, that's all it is. It's a double. If I make it an int, that's all it is. It's an integer. So if we want to utilize some of these cool methods, we can put that data, that integer primitive data type, into an integer class, and then we've got a whole lot of methods that we can utilize that will benefit us and save us a lot of code writing in the long run. A wrapper class is a class that is wrapped around a primitive data type and allows you to create objects instead of variables. So when we use the wrapper classes, we're actually creating objects and not primitive data types. The wrapper classes are immutable, which means that once you create the object, we cannot change the object's value, just like a string. We can't. If we try to change the value, it's actually going to create a new object behind the scenes. On page 588 or 558, wow. So let's see. So here on page 558, it's got this. Here are some methods that are built into these different wrapper classes. And so this is called, well, this particular class is the character class. So this is just dealing with one single character. And we can take a character and we can check to see, is it a digit? So if that character is a 0 through a 9, it's going to return a Boolean true. We can check to see if it's a char. So if it's alphabetic, if it's anything but a numeric, it's going to be considered a letter. We also have is a letter or digit. So we can check to see, is it a letter or is it a digit? So is it alphabetic, is it numeric? And that will return a true. We can check to see if that character is lowercase. We can check to see if that character is uppercase. We can check to see if that is a space character. And we also can see if it's a white space. So what's the difference between a space and white space? Well, if it's a space, it's going to return true. If it's a white space, which could be a tab, it could be a new line character. So basically, think of a white space as any non-printable character. And guess what? A space is also a white space. So if this is true, this is also going to be true. But if it happened with, you know, the /n for new line, that would come across as a white space. So let's go ahead and open up this character test. So open up the chap 9 package, and here is the very first one, character test.java. So we come in here, we've got string input, we've got char ch, and we're going to basically be using a JOption pane. We're going to say input equals JOption pane.show input dialog, enter any single character. And then what we do is we say, so remember, a character is a single character of data. It's also a primitive data type, which means it is numeric. So even though it's a letter, could be a letter, it still is numeric. That's kind of going back quite a few chapters. But so what we're going to do is going to say input.char at 0. So what's nice about this is if I typed in a whole bunch of stuff, it's only going to grab the very first character at position 0 and put that into CH. Because CH is a char, only one item can go in there. Now here's what's cool is we're going to say, if that character, so this is the wrapper, the character, and dot is letter. Now here's what's nice. This is a static method, which means we can use it right out of the box. So what's nice about that is, just like any of the wrappers we've seen so far with the parse int and the parse double, is we can say is letter, and with that character ch, if that's true, it's going to say that is a letter. If that character is a digit, it's going to display that is a digit. If it's lowercase, it's going to print that as a lowercase letter. If it's uppercase, it's going to print that as an uppercase letter. If it's a space, it's going to say that's a space, and it's going to say that is a white space character. So if it's a non-printable character, which is a white space, it's going to do that. So let's run this. And our J option pane comes up, and let's go ahead and type in a capital letter A and click OK. And it comes up and says that is a letter. Oh, it also says that is an uppercase letter, and then the program ends. Let's run it again, and we'll type in the number 6. So let's type in the number 6, click OK, and it comes back and says that is a digit, and it basically stops the run of the program. Let's run it one more time. This time, let's just type in a space, click OK, and it comes up and says that is a space, and it also says that is a white space character. So I click OK, and it's the run of the program. So nice wrapper class. So if I were to come over to this character and I just type the period behind it, we can see that there is, is alphabetic, man, there's all kinds of stuff. Is high surrogate, is identify ignorable. So there's a whole lot of different methods that come with this particular class. Here looks like we have a lot of constructors, or constants. How do I know they're constants? They're all uppercase. And here's some other items as well. So as you can see, the character class has a lot of different methods that comes with it. Any questions on the character wrapper? So how could we utilize this in a real-world situation? So let's open up customer number. So here's what we want to do is we want the user to type in 3 letters and 4 numbers. That's what our customer numbers are always 3 letters and 4 numbers. So in order, we have to then make sure that they type that in just like that. So we got a J option pane, and we say enter a customer number in the form letter, 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 number, 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 number. A new line. And LLL equal letters, and NNNNN equal numbers. And then we're going to say if is valid input. Well, that right there tells me that's a method. So if I come down here, sure enough, there is valid, and we're passing it the string cust number. And what we're going to do is we're going to have a Boolean data type called good so far, and we're going to make it equal true. We're going to create an int I, and we're going to set it to 0. And we're going to say, if the cust number dot length is not equal 7, we're going to say good so far equals false. So the very first thing we got to make sure, is it 7 characters? Is it 3 letters and 4 numbers? And then we're going to say while good so far, so while this is true, and I is less than 3, right now it's a 0, so guess what? If the length of the customer number was greater than or less than 7, good so far is going to be false. This while statement will never go into this while statement because this guy is false. So since it's true and the I is less than 3, we're going to come in here and we're going to say if not, see the exclamation point in front of it? If not is letter customer number dot char at I, so the first time it's 0, so let's look at the very first position. We're going to make good so far equal false, and we're going to add 1 to I. And so what happens there then, so if this right here gets set to false, it's going to come back to this while statement. It says, is that true and that true? Nope, that's false. It's going to drop out of that while statement. But if the first letter if the first character is a letter, it's not going to change that to false. It's going to come back around and check the next one. So char at 1. If that's a character, it's going to come back around. It's going to keep doing that. At the same time, it keeps adding 1 to I. Then once we've done for the first 3, because that's all we want to do is I less than 3, so once it gets to 3, because we're starting at 0, 0, 1, 2, we're going to go to the next 4 characters. We're going to check the next 4 characters. And while good so far, and I is less than 7, so we basically been adding 1 to I, we are going to say if not character dot is digit cust number dot char at, in this case it's going to be position number 3, which is the 4th position. If that's a digit, it's not going to change this good so far to false. We're only going to change it to false if it's not a digit. We add 1 to I. We keep doing that, and then we're going to return good so far. So how are we going to use this guy? So we come back up here, and once we get, so this is going to return a true or a false. If it's true, it's going to display that's a valid customer number. Else, it's going to display that is not a proper format of customer number. New line, here's an example, ABC 1, 2, 3, 4, and then we exit the program. So pretty cool, kind of a nice way to make sure that we have a customer number formatted in the exact format that we need. So let's run this. And here is our J-option pane. Enter a customer number in the form LLL, NNNN, LLL is letters, NNNN is even numbers. So let's type in AAA111. We click OK, and it comes back and says that is not in the proper format of customer number. Here's an example, ABC 1, 2, 3. Ah, I forgot my 4th number. Okay, so I click OK. I run it again. And this time I'm going to type in AAAA111. So it's 7 characters long. I click OK, and it comes back and says, oh, that is not the proper format of a customer number. Here's an example, ABC 1, 2, 3, 4. I click OK. Ah, I typed in too many letters that time. So let's run it one more time. And this time I'm going to type AAA1111. I click OK, and it comes back and says, that is a valid customer number. Now, the one thing we didn't do that we could is we could make sure that they're uppercase letters. So a lot of times what we'll do is instead of checking to see if they're uppercase, is if they type in a lowercase, we'll just go ahead and convert it to uppercase. That'd probably be the easiest thing to do, is not bother customers, hey, that everything has to be uppercase. Let's just make it uppercase for them, and then that type of thing. Any questions on that? Yeah, and the way we could do that is on page on page 563, it's got this character case conversion. And what that consists of is we can actually say char to lowercase, and that's going to return a lowercase equivalent of that whatever that char is, and char to uppercase. So here's how that looks. So again, this is all part of the wrapper class. So character, here's the character wrapper class dot to lowercase a, and that's going, when we print that out, it's going to print a lowercase a. If I were to say now this is saying character to lowercase a, well, it's not going to do anything at all because it's already lowercase. This one says take the lowercase a when I convert it to uppercase. So now, what's going to happen if I said to lowercase asterisk? Nothing, because there's no lowercase asterisk. Same thing with any of these other special characters like $, and ampersand, and percent. So it's not going to do anything. So let's open up circle area. And it says this program demonstrates the character classes to uppercase method. So we've got 4 local variables. We've got double radius, double area, and string input, and then char choice. We're using a scanner keyboard. Now look at this. We got a do while loop. This loop is going to execute at least one time because the check is at the end. So we come in. We're going to say enter the circle's radius. We go ahead and say radius equals keyboard next double. So we're expecting a double. We then do a next keyboard next line. And we say area is equal to math.pi times radius, because the area of a circle is pi times radius squared. And then we print f, the area is 2 decimal places area. Then we ask, do you want to, now this is the whole purpose of this whole program is right here. Do you want to do this again, y or n? We go ahead and get the input from the user, and then we say choice input.char at 0. So again, I could type in multiple characters. It's only going to grab the very first character because we're using char at 0. We put that into choice, which is a char data type. And it says while character.to uppercase choice. So here's what's nice. If I typed in a lowercase y up here, this to uppercase is going to take my choice, make it uppercase, and it's going to see if it's equal to an uppercase y. If that's true, it's going to come back into this again. So let's run this, and we're going to type in 12 as our radius, hit the enter key, and it says the area is 452.39. And right here it says, do you want to do this again? I'm going to type in a lowercase y, hit the enter key, and now we're going to we'll type in 18, and the area is 1017.88. I'm going to type a lowercase n, and then basically the program ends. So the to uppercase is a really nice feature, especially in this case when we're asking the user to provide us, do you want to do this again, y or n? Okay. Now over here on page 566, we've got more string methods. So these are methods that are built into the string class. And first thing we talk about is starts with and ends with. So we might have a string, so string str is equal to 4 scored 7 years ago. I can say if str starts with four, the string starts with 4. Else, the string does not start with 4. So it's going to look at these first 4 characters of this string and see if they equal capital F-O-U-R. Has to be a capital F, by the way. So here's some other string methods that we can utilize as well. We've got starts with, and we're going to use a string variable. Ends with, string variable. Notice that it returns a Boolean data type. It's going to return true or false. Ends with does the same thing. Boolean region matches. Now here's what's neat about this one is we got int start, and in the string we're going to utilize, and then the int start to, and then int end. So what this is saying is we're going to look at, so this method returns true if the specified region is calling string matches a specified region of a string passed into string. So we're looking at 2 different strings. And we're going to tell it where to start on this string, where to start on this string, and then the end parameter indicates the number of characters in both regions. So if I want it to start with whatever this is, so this time, so up here we're looking to see what it starts with, in case F-O-R, F-O-U-R. This one we want to see, does this string have the same number, so the end, so like here in this end, if I said 5, it's going to look at the first 5 characters of this string and the first 5 characters of this string and see if they match. Okay? So that's basically what region matches does. It's looking at 2 different strings. And then we've got region matches down here. But guess what? It's overloaded. Why? Because now we've got this Boolean ignore case. If I put in a true here, it's going to look at those first 5 characters of both strings, and if that's set to true, it's going to ignore the case, which is kind of nice, because if I'm looking just to see if the same text is there, I can say ignore case, and even though it's got a capital letter F over here and a lowercase f over here, it's going to match up just fine. Okay. So the next example we're going to look at is this thing called the person search. And there we got our scanner keyboard, and we basically got our public static void main. We've got string lookup, and I've created a string array of people. Okay, so string left and right square bracket people is equal to these braces. So it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sets of people. It looks like it's last name, first name. So we create our scanner keyboard, and then we go ahead and say print, enter the first few characters of the last names to look up. We take whatever we typed in and put it into lookup. Then I'm going to say here are the names that match, and I'm going to use a for loop. So we're going to use an enhanced for loop. So I'm going to grab this people array, and I'm going to grab each element one at a time and throw it into person. We're going to say if person dot starts with lookup, we're going to basically print that person out. Okay. So that's kind of cool. So whatever I type right here in this lookup, it's going to say, hey, if one of these starts with that, it's going to then print that person out. So if we run this, and I'm just going to type in a capital D-A-V and hit the enter key, and it says here are the names that match. There's Davis, comma George, and Davis, comma Jenny. Let's do this. Let's run it one more time. And this time I'm going to type in uppercase R-U-S-S and hit the enter key. And look at that. Here are the names that match. Russert, comma Phil, and Russell, comma Cindy. So pretty straightforward, nothing too wild. Okay, so the next thing we're going to look at, these are string methods. We've got index of char and then ch, and that's going to return an integer. Index of char and then the int start. So right here's what's nice about this. It says it searches the calling string object for the character passed into ch. If the character is found, a position of the first occurrence is returned. Otherwise, a -1 is returned. This one here, we can say search for this character, but start at this position in the string. If I say index of string str, this will basically take this string. This one is looking for just characters. This one is looking for a string within that other string. Again, it's going to return an int where that resides in the string. Again, if any one of these aren't found, it's going to return a -1. I can do the same thing with an int start. I can tell it where to start within that big long string to start looking for this other string. I got index of, last index of, and what that's going to start at the end of the string and look backwards for that character. Same thing for this index of, where I can tell it where to start. So it's going to basically, again, if I tell it to start at the 12th character, it's going to start at the 12th character and then work itself backwards. Last index of string, same thing. Last index of string, where to tell it where to start, same thing. Yeah, so let's look at, they actually don't have any examples. I created one called index of. Let's open index of. And so here's what we got. We've got two strings. I've got str and str2. The first one says 7 years ago. The second one says and a 1, and a 2, and a 3. I've got int first and last, so it creates two primitive data types, integer primitive data types called first and last. It's got int position and it's equal to 0. So the first thing I do is I say first equals str index of r. So it's going to basically, again, first is an integer, so it's going to look for the very first. So index of here, it's going to start on this side and go in. Oh, it's found an r right there. So there's 0, 1, 2, and 3. When I do last index of, it's going to start at this side and start going back, and oh, there it is right there, and I'd have to count that out, but it's going to return that position of that character, R. Then it says the letter R, notice it's got the backslash single pick, backslash single pick, so it doesn't, so it'll actually put it picks around the R, appears at position first. The letter R last appears at position last. And then it says the letter R appears at the following locations. It's got position equals str index of R. So we basically, now it's basically going to be at this position right here. Okay? And it says while position not equal -1, so we had to make sure we got an R, we found the R up here. It's going to say system.out.println position, and then position equals str index of R position plus 1. So what that's going to do is this first println is going to print the number 3. What we do then is we say position plus 1. So we basically are now sitting at this space right here, and it's going to find the next R after that space, which happens to be that R, and then it's going to go one ahead and look for the next one, which is that R, and then basically it's not going to find any more. So it should find 3 R's and tell us the position of each of those R's. So let's do that real quick. Let's just run real quick. We'll worry about these here in a second. Oh, I'm sorry. Let's do this. This is going to look at the last index of. Okay. So this next one is going to say the letter R appears at the following locations. This time we're going to start at the back of the string. So we're going to start here and then tell it the R positions this way. So that's basically what this guy's going to do right here. Then we're going to look at this string, and we're going to look at the word and. So this guy says the word and appears at the following locations. So this time we're using string.index of and we're going to do the same thing. We're going to, as long as it's not equal to -1, we're going to print the position, and then we're going to add position +1 to go past that, and then we're going to show the same things in backwards order as well. So that's all they do. So that's the only difference between this group of code and this group of code, is one starts on the left and goes to the right, the other one starts to the right and goes left. So let's run it. And there we go. So the letter R first appears at position 3. The letter R last appears at position 24. The letter R appears at the following locations, 3, 8, 24. Now we're going to go backwards, the last index of. The letter R appears at the following locations, 24, 8, and 3. The word and appears at the following locations, 0, 10, and 20. Then we do the last index of, and the word and appears at the following locations, 20, 10, and 0. So, kind of a nice way to find either a character or a string of text within another string. So any questions on those? Okay. Now, another thing that we can do with strings is I can basically extract what are called substrings. So again, these are all built-in methods for strings. So I've got string, substring, int start. So I can tell it where to start, and it will basically start that position and grab everything all the way to the right-hand side, from that starting position to the right. So this one's kind of, I could say start at position 3, and then from 3 to 15, it's going to grab everything all the way to the right-hand side. Or I can tell it where to start, and I can tell it where to end. So only grab this section of text within that string. So both of these will return a string. Now I can say get chars, int start, int end, char array, int array start. So what this says, this method extracts substring from a calling object and stores it in a char array. The argument passed into the start is a substring starting position. And the end is the end position. So I can tell it to grab this section of code using start and end, and then put it into a char array. Let's see. The start array parameter specifies the starting subscript within the array where the characters are to be stored. And then lastly, this right here, toChar array, is going to automatically put it into a char array. So this method returns all the characters in the calling object as a char array. So here's kind of how this works. This whole page right here, again, I've got that put into it. I created the example, and it's called substring example. Oh, where is substring? Maybe it's just called substring. Yep, yep. It's just called substring. My bad. So here's my public static void main. I've got string full name, Cynthia Susan Lee. String last name is equal to full name dot substring 14. So if I did 0, 1, 2, 3, 4, 5, 5, here's 14, so it's going to grab everything from this to the end, which is all Lee, and that's going to be put into last name. And then I can say the full name is full name, the last name is last name. So if we can see last name, it started at position 14 and grabbed everything to the right-hand side. Middle name is full name dot substring 8 through 13. So I'm going to assume this is 8 and this is 13. So it's going to grab just that, and then it's going to print the middle name. Then we create so look at this, we're going to create a char array. So here's char, left and right square bracket, name array equals new char 5. So the full name dot get chars 8 through 13, and the name array 0. So this is going to basically grab everything from Susan to here, and is going to put that into a name array. And so the value of the array R, and it's going to use a for loop to display that array, that char array. So we got int_i equals 0, so it does that once at the beginning. While I is less than the name array dot length, we're going to go into this, and we're going to print each character one at a time. Notice we're using a print, so it's going to print each character and a space, and it's going to basically print it all on one line. Then I create another char array called name array 2. And name array 2 is going to be equal to full name dot char array. So it's going to take the entire thing, and put it into this name array 2. And then we're going to say the values in the array are, we're going to do the same exact for loop and print out each character. So when we run this, so up here it says the full name is Cynthia Susan Lee. Last name is Lee. The middle name is Susan. So it grabbed 8 through 13. The values in the array are SUSAN. We should have had another print. I should have done as a print ln at the end. Yeah, my bad. And then the value, so I should have done this. /n right there. Oh, not there. Should have done it down here. /n. Yeah, let me run it again. There we go. So the values in the array are SUSAN. So it ran that for the middle name. And then it grabbed the full name and threw that in name array 2. And the values in the array are, and then you can see it prints out each letter followed by a space. So any questions on these wrapper methods that are basically, again, very powerful? Okay. So let's take a look at the string analyzer. Let's take a look at this code. So it basically says, okay, we got 1, 2, 3, 4, 5 local variables. We got string input. We've got an array of chars. We've got integer letters equals 0, integer digits equals 0, and integer white spaces equals 0. We've got a J option pane. Enter a string. We're going to say input.toChar array. So we're going to take whatever is in the input, convert it to a char array, and put it into array. Then we're going to go through that array one letter at a time. Okay? So int_i equals 0, and while I is less than the array.length, we're going to go into this guy. If characters.is letter, and then we're going to look at the whatever position we are in that array, one character at a time, we're going to add 1 to letters. Else, if it's a digit, we're going to add 1 to digit. Else, if it's a white space, we're going to add 1 to white space. Then we're going to basically display everything. We're going to say the string contains that many letters, that many digits, and that many white spaces. So when we run this, the example they want us to use is 99 space red space balloons. And we click OK, and it comes up and says, that string contains 11 letters, 2 digits, and 2 white space characters. Okay. The next part of the chapter on page 576, it's got methods that return a modified string. So these are all methods of a string, and we got string, concat, and then string. We got string replace. So it's, again, this method's going to return a string. Replace, old char, new char, that's going to basically also return a string. Then I got string trim. And what trim does, well, concat is going to do just what you think. It's going to glue 2 strings together or multiple strings together. Replace old char, new char, that's exactly what you think it's going to do. If you tell it to replace all the T's with a D, it's going to do just that. Trim is pretty powerful. It's going to remove any beginning spaces and trailing spaces from that string. So if we're getting data from the user, and the user accidentally types some spaces in the front or some spaces at the end, trim will automatically take those trailing and leading spaces off of that. So here I've got string full name. String first name is equal to Timothy space. Last name is equal to Haynes, no space. I can say first name equals first name plus last name. Now we've seen that in the past. This is nothing new to us. Or I can say string full name equals Timothy and Hayes, and I can say full name equals first name dot concat last name. So this says go ahead and glue to the end of first name, last name. I think I have an example of that. Is it the modified string? Let's take a look at modified string. Yeah, there it is. So just like I showed, full name, I got first name equals Timothy, last name equals Haynes, and then we're going to make full name equal first name plus last name. And there we have it. Or I could actually do full name equals first name concat and last name. And that will do the same exact thing as that guy up there. I don't know why I didn't do that. String str1 is equal Tom Talbert tried trains. Then I've got string str2. So str2 has got null value right now. I can say str2 equals str1 dot replace the uppercase T's with an uppercase D. Then I'm going to print str1, and then I'm going to print str2. Here I've got greeting, space, 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 hello, space, 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 greeting 2. Greeting 2 is equal to greeting 1 dot trim. And down here I'm going to say print asterisk, greeting 1, and asterisk. So it's going to glue an asterisk at the beginning of each one of those, and we're going to do the same thing for greeting 2. So when we run this, there I have Timothy Haynes. So there, print the full name. Then Tom Talbert tried trains. When I replaced all the capital T's with a capital D, it's Dom Dalbert tried trains. And then here, when I have spaces in front of hello and end of hello, notice that here's my asterisk, here's a bunch of spaces behind it. But when I did a trim, notice that all of those leading and trailing spaces are gone. So we've got dot concat, or you can just use the plus sign. Either one of those works as well. I don't think the concat's any more powerful than using the plus sign. The replace is kind of nice, and then the trim is really powerful, especially when you're getting data from a user. We can clean those up by making sure all the leading and trailing spaces are gone. It's also powerful too for basically maybe we're trying to get a full name and split out first, middle, and last. We might grab, well, we might include the middle name that has a trailing space, or we can clean that up with a trim. Any questions on those? We also have a static value of methods. It says the string class has several overloaded versions of a method named value of. This method accepts the value of any primitive data type, and its arguments returns a string representation. It says table 9.7 basically explains those. I got value of. I can put in a Boolean. If it's true, the argument is false, the method returns false, and it's going to return a string. So I'm basically taking a Boolean and converting it to a string. Value of char, this returns a string containing a character passed into C. Value of char array, this returns a string of all the elements. So it basically takes a character array, pushes them all together, and throws it into a string. I can say a double number, value of, that converts it to a string and puts it into a string variable. Value of a float number, converts it to a string, puts it into a string variable. Same thing with int, same thing with long. If we take a look at the example called value of, we can see what those look like. So here I've got Boolean B equals true. I've got a char array of letters A, B, C, D, E. I've got a double D, 2.498157, and then an int 7. So I'm going to print string.value of B, string.value of letters, string.value of letters 1 through 3. So it's going to basically grab B through, so 1, 2, 3, just one B, C, D. Print value of D, which happens to be that double, and value of I, which happens to be that integer. Now when I print these, this is no longer a numeric value, it's a string. Same thing with this 7. Same thing with true, that is just a string, that's a string variable now. It's an actual TREU. So this guy converted a Boolean to a string. Letters, so look at that. Letters was an array of characters, and now it's a string. And then when I said 1 through 3, so there's 0, 1, 2, 3, B, C, D, there's B, C, D, there's our double, and there's our integer. Okay, that's all I want to cover for chapter 9 tonight, so let's go ahead and do some exercises. And let's go ahead